That was really, really awesome. And with that, we'll go straight to our next sessions. Please join me in welcoming Drew Banin, a co-founder at dbt Labs, a pioneering startup in analytics and engineering. More importantly, they're also looking to establish a presence in Cluj, so pay very, very close attention. It's going to be one of the most nerdiest presentations I've seen. I've got an early preview, so I'm very, very much looking forward to it. So he's a co-founder at dbt Lab. He spearheads the development of dbt, a tool embraced weekly by over 40,000 companies to streamline data organization, cataloging, and knowledge distillation with their data warehouses. And I'll let him share more, but he'll share into the transformative potential of playing sheet music with dbt, with a database. And if this sounds pretty crazy to you, it did to me. Just like watch and see and be inspired. It's really, really cool. I'm really looking forward to that. And please join me in welcoming Drew on stage at Techsylvania. Thank you so much for coming here.
Hello, everyone. My name's Drew. I'm one of the co-founders at dbt Labs. I'm so excited to be here in Romania, and it's been a pleasure meeting so many of you so far this week. I'm presenting off my own laptop, which means that I'm making it hard for the AV folks here. I'm going to talk to you about something that I built just personally. I am here representing dbt Labs. I'm one of the co-founders there, and we do indeed do work with data and analytics. And in the process of doing data and analytics work, I found myself coming into contact with databases over the past 10 or so years. And so I've been very intrigued by databases in general. And I've always wondered, like, how do they actually work under the hood? So we're going to talk about a database that I built. It's called dbdb, because my name's Drew Banin. It's a database. We're also going to, at the end, talk about music. And we'll come back to that point a little bit later. So, right, I wanted to learn how databases really work. I've taught people how to use databases, how to write SQL, how to think about running queries. But I got to this point where I just didn't know, like, what's the database actually doing under the hood? And so I wanted to be able to explain that better to people that are learning, and so I figured the best way for me to learn is to try to build one and encounter these problems myself and figure out why does the database do what it does. So this is all about having fun. This is not about academic rigor. It's not about sweating the details. I'd recommend a degree in computer science if you want to know how to do this for real. This is about having fun. So dbdb is a pure Python columnar database. I built a SQL parser and a query planner. It supports column encoding and compression and a bunch of different operators. If you don't know what those words mean, that's OK. That's exactly what we're going to talk about first. So databases do basically two things. The first thing that they do is store and retrieve data, and the second thing that they do is execute an operator graph. So first we'll talk about storing and retrieving data. So if you've used a database before, you might be familiar with the idea of a table. You would say, I'm going to query a table or select from a table. But actually, the impetus for this project for me was like, what the hell is a table when you get down to it? And it turns out tables are files. Data lives in files on a computer, basically. And so if you think about databases, the goal is to answer questions very quickly. And here, everything we're going to talk about is a special type of database called a columnar database or an analytics database. So this is not the type of database that would power your website like an e-commerce application. This is a database you would use for doing analytics. So we want it to go really, really fast. And it turns out that for most types of queries, basically a database does two things, right? It reads data from storage to get access to data, and it applies some sort of computation to that data. So if you have really big data sets, it turns out that the amount of time spent for most queries is dominated by retrieving data. So that's the part we want to optimize, is the idea of reading data from storage. So there's 3 tools that we can use to do this very, very quickly. And the first thing is the idea of storing data in columns. So here's an example query. I have a pointer that doesn't work. So here's a query, select first name from people. And in this case, we only want one column, the first name column, from the table called people. And so that means we don't want to waste time reading the data in the user column and the last name column, because it's irrelevant to our query. So in a columnar database, you can address, that's the word we're going to use, you can address that column first name and skip reading any of the data about irrelevant columns. So That's actually what goes into the file format, that's what we'll call this, that stores data in a table. So here's the example, kind of overview of the file format that I built. And it comes in two parts. The first thing is called the table header, and this stores column names and types and information about the different columns. And then also it stores data pages. And so this is the actual data in the columns itself. So the cool thing here is for our query, select first name from people, we can find in the header, which is a small amount of data, we can find the first name column and know what type of data it is. In this case, it's a string. And then that 0x456 there, that's a pointer into the data file itself. So it says, you only need to read this small chunk of data inside a much bigger file, because those are the only data points germane to the query. So in this way, we can skip reading irrelevant data, and the fastest way to do something is to not do it at all. So we get to not read data that doesn't matter. Okay, the second technique we can use is called compression. So I'm not talking about WinRAR or 7-zip or any of those things. It's a different type of compression. And so the big idea behind compression is making data take up less space. Because again, we want to read data as quickly as possible. If there's less data to read, that will happen faster. So this big insight is that the more you know about a data set, the better you can compress it. And actually, if you kind of look into this stuff, it turns out that artificial general intelligence is a perfect compressor. And so these two fields are kind of related in interesting ways. But the idea is we have knowledge about a column like is returned. So imagine this is an e-commerce data set, and only 2% of orders are returned. Most of the values in this column will be the value false. And so it doesn't make sense to store the value false over and over and over again. Instead, we can store a run of values. So we say the value false is repeated 4 times, followed by the value true. So this is a lot faster. Imagine your query says, how many orders were returned last month? Well, we don't have to count false up a million times. We can just see all the repeated chunks and kind of add them together. So this is much faster. This is called run length encoding. This is a special type of compression called an encoding of data. And it works best when values are repeated very often. So you can imagine this works really poorly when values are not repeated, like if it was a birthday column, and most people don't necessarily share exactly the same birthday sequentially. So in that case, you'd actually be storing twice as much data, because you store the birthday itself repeated 1 time, and so you're wasting space in this case. So you have to be very careful about how you compress data. The other type of encoding I want to talk about is called dictionary encoding. So in this case, we have a list of countries, and Philadelphia is not a country, I should say city. But we have a list of cities, and these are relatively long strings of text. And so you can imagine if this was 1 million rows of data, we're unnecessarily storing the string Philadelphia, which is where I'm from, and Cluj many, many times over. So instead, we can set up a sort of dictionary lookup at the beginning of the column. And we can say the value 1 represents Philadelphia, and the value 2 represents Cluj-Napoca. And so then we just store kind of the index in the dictionary, which ends up taking less space. So this is another technique you can use. It works great for things like country names or kind of labels that will show up many times over, especially when they're long. OK, the last technique I want to talk about is reading as little data as possible. Because again, the fastest thing you can do is nothing at all. So what we can do is we can take our data, and we can break it into what we call row groups. So a row group is typically about 128 megabytes or something like that. It can be whatever you want, but like a large amount of data. And then we can store statistics on the values inside of each of these groups, or sometimes called pages of data. And so in this case, it's a little bit cut off here at the bottom, but there's a filter on this query, and it says select first name from people where favorite number is 10. And so we can see there's 2 row groups, and only the first row group contains values, could contain values like 10, because the minimum value is 2 and the maximum value is 15, and then kind of here below, it's much higher, the statistics stored for this row group. So we can actually just skip reading that second row group. We don't need to read 128 megabytes of data, which might have to happen over the network, and so our query can run a lot faster. OK, that was reading data from storage. We're going to go back to this idea of executing an operator graph. So here's an example query. It concatenates a first and last name where people equals Drew. And so to execute, we call these things operators, like filtering data or aggregating data or joining data. They kind of do what you would expect. So if your input data is a list of first names, and you have a filter that only allows values where the first name is equal to Drew, then that will drop any other record that is not Drew. Another type of operator could be sorting. So if you order your data set by a date time, something like that. Here, we don't actually drop any records, but we do want to sort and reorder the records based on some specified key. And then a really cool thing that you can do once you've assembled this operator graph is you can reorder these operators. So here we have 1 million rows, just say in our people table. And then we're going to aggregate that data, but then we're going to filter it to where only the name equals Drew. And that means we're going to aggregate a lot of values that we don't actually care about, like names like Vlad, for example. So instead, what we can do is swap these two operators and do the filter part first. And so this is what a database optimizer does. It reorders your execution graph to make your query run faster, usually by doing less work. So to put it all together, this example query, we will scan a table, like the people file. We will apply our filter to drop any rows where the first name is not Drew. It's called a projection. We will project a full name value. And finally, we'll limit it to the first 10 records based on the SQL query. So if you do all of that, you will have built a database, and you too could be on stage doing a demo of it. So does everyone want to see a demo? Is that OK? Cool. So this is the interface for dbdb, which, as you can see, there's a box where we can write a query in the top left. And so I can pick an example query here. Like, let me pick this kind of simple one. So what we're going to see here is called an operator graph. And in this case, it's sort of live streaming from the server back to the website. And so we're generating a series of numbers from 0 to 100, basically. And you can see that happening live. And so we can also see the results of that query here, so the numbers from 0 to 100. So it is a database. It does work. There's more interesting things we can do with dbdb, though. So here's an example of doing some math. And if I look at the query plan, it looks kind of similar. And if I look at the results, we see x and y coordinates and colors. And so in dbdb, if you return columns with x and y coordinates, we can plot them, if you can see that on the top right. And so this is what happens when you add two sine waves together. The last thing I want to show you is the Google Sheets integration of dbdb. So in this case, this is a Google Sheet ID, which you cannot see. Take my word for it. It's a Google Sheets ID. And so I can query this Google Sheet, which would look like this, which you also cannot see. But there is a Google Sheet here. And so one of these cool things that we could do is we can query Google Sheets and sort of get data back into the database. So if we put this all together, the idea of like adding sine waves and querying Google Sheets, this is where the kind of idea of playing sheet music comes from. So before, when we plotted, or when we returned x and y values, we could show it as an image. But here, if we return values like a note to play, and a starting time, and a length, we can actually play that as music. So now we're going to see if the audio works. And let me turn this way down so I don't bust anyone's ears. And you might want to take a big step away from the speaker just in case. OK. Well, it's coming through my laptop. Can anyone hear that? A little bit? In the back, can you hear it? OK, we're going to roll with it. So that was a scale. So I'll show you another type of query. Let me reload this. OK, here's another type of query. So let's do, anyone here ever seen the movie Howl's Moving Castle? It's like music. Yeah, you've seen it. It's a good movie. OK, here's the soundtrack played via Google Sheet music. OK, here's Howl's Moving Castle. Let me do this. So this is the frequency domain of the music. And I'd like to think this is business intelligence, kind of, but for music. We can also see the time domain, which looks like that. Great. So there's a couple other things I want to show you that are just kind of fun. This is like a fun riff. At this point, I'm going to do a rock concert for you, like an opera, rock opera. So I'll run this query. This is a song I like. So it's really cool. And again, all we're doing is we're taking our kind of results and we have it, play this note at this octave at this time, and then we're visualizing it, on the either time domain or frequency domain. So I just want to show you a couple more, and we're gonna keep this light. We're gonna keep it loose. This is a cool one. I built a GPT-4 table function. This is called, and so actually what's happening here is I can just ask GPT-4 to generate a data set for me. In this case, I'm going to ask it to play the song Happy Birthday. So is it anyone's birthday in the room, like this week? Happy birthday to you. What's your name? OK, let's all sing her happy birthday together along with Sam Altman. So we're going to run this query, and we're going to get data back from GPT-4, and we're just going to do a quick, we're going to try that one more time. OK, so we look at the results. This was mind-blowing when I did this. I asked GPT-4 to generate a CSV, basically, of the song Happy Birthday, and it mostly works. So on the count of 3, 1, 2, 3. Day to you. You're all going to sing too, right? It's not just me? No one's going to sing? Happy birthday to you. Okay, thanks everyone for sticking with me. So I'll play one more, and then I think I don't want you to have to boo me off stage or anything. But this is a song I really like. It's by Aphex Twin. It's called Avril 14, and I'll just let it play, and then we'll go back to the presentation there. Okay, thank you so much. Okay, that was dbdb. I've got just I think 2 more slides here. So you can't see it up top, but it says databases are never finished, only abandoned. I think that's a Picasso quote, I'm pretty sure. So I've been working on this for about 3 years, on and off, and honestly, it's been conference driven. So every time I go to a data conference, I work on this a little bit and make it a little better and talk about a new thing. So I'm very grateful to be able to be here and share it with you, and also appreciative of your patience as we work through it. So some of the things I'd like to do in the future, maybe build a query optimizer. Haven't actually built one of those yet. I'd like to make this distributed and run it on a bunch of Raspberry Pis in my closet at home. And I would, really, I love the idea of teaching about databases. I was happy to be able to share with you a little bit about how they work under the hood. So I'd like to make a YouTube series someday on, how to build your own database. Again, just, for intuition and learning. That kind of gets me to the last point I want to make. And, we talked about how I'm a co-founder at DBT Labs, and we've been doing this for about 8 years at DBT. And so one of the things I found and sort of wanted to share with you is that as a founder, there are things that inspire you and motivate you at the outset and give you, drive to get through the hard times. But over the course of 8 years, what I found is the things that motivated me when I was 23 don't motivate me exactly the same way at 31 anymore. So this is one of those sources of passion for me. I love learning. I love teaching. I really, really like making music. And I just want to say to all of you, be conscious of where your energy comes from and never be afraid to try something new and see what you're capable of. So that's all I got. We are indeed hiring in Cluj. We're going to be opening an office here. So if you're interested or you know someone who might be, I'd love to connect with you or them. We're hiring engineering managers and software engineers here. And you can't quite see, but there is a URL for this database online. It's dbdb.fly.dev if you want to check it out. I'm at DBT Labs. We're getdbt.com. And all the code for the database itself is open source on GitHub. So thank you all.